now?
Yes, yes, we can see your screen.
Okay. Thank you very much. So, as Professor Samsu just said, in machine learning, we are going to be dealing with a lot of data, and regression, all of this regression is not an exception. For this particular one, I will also like to give a quick overview of the machine learning pipeline. We know that we need to have a data set for us to make any prediction. This data set can either be created by ourselves or we use an already created data set. Having that data set, we need to clean it. We term it here as data cleaning. Data cleaning requires you to look at your data, look at missing information, look at the data, is it suitable for your task? And then you extract those particular tags that you need. We term this as feature engineering. After extracting the section of data that you need, you divide some into training, while some will go as testing, as new data here. This training data set requires a learning algorithm. This learning algorithm are the regression models. We have neural network and we have advanced models such as transformer and the rest. After applying this learning model to your training data, what you have here is called a model, or should I say train model. When you have a train model, you compare it with a new data or your testing data. You test it and validate it. After testing and validation, you evaluate your model. And if your model get a good score, then you can say that you have a nice model. Else, you have to come back to the drawing board. However, at our stage, we see that we have so many sections here. But at our stage, we see that we are, as machine learning enthusiasts, machine learning beginners, we spend most of our time on the data sets, on preparing the data. While these other advanced models, such as the training model, the score, and the rest, those ones are advanced machine learning. In fact, we are going to be looking at them as black box for now. So with that, we can say that you are going to spend 70% of work in machine learning in your data set, in getting your data set and understanding your data set, preparing it so that you can plug it into some already established model. When you plug them into already established model, then you are good to go. This already established model, we are going to be looking at them as black box for now. Black box in the sense that you don't see what exactly is happening inside, but you can know what your input will be, and of course, anticipate what your output will also be. And also see how you can evaluate your model such that you can get to a benchmark. Today, we are going to be taking a particular data set as a case study, as earlier introduced. We are going to be using this US
Okay, Sayed,
pumpkins
close your
as our
terminal.
data set.
Close your terminal, Sayed, so that it is better to see.
Okay.
Yes.
All right. So we are going to be using this data set as the case study for this particular session. We will see that this terminal, this data set consists of so many information, but I think I have one small plugin here. Okay. So with this plugin, we can see our data set here. This data set have so many information. It has the headings here, which says city name, type, package, variety, up to what? You can see prices, origin, high price, and low price. So this particular data set Okay. So moving at that, you can see that's just an overview of the data set. So this data set, as a machine learning enthusiast, when you have a data set, your next question is, what do you do with that data set? What you can do with that data set depends on the information the data set consists and the task at hand. And then if you are able to manipulate your data set very well, some will call it data wrangling, you can twist it, then you can get a particular information that you want. So while wrangling data set, these are some of the things that you come in contact with. Some of them are, you need to know the libraries for processing those data sets, such as pandas, numpy, etc. You also need to know how to import the data set in the various versions. Very important, you need to know how to handle missing data, because one missing data can trigger performance or it can misinform a particular information. So knowing that a data is missing and removing it gives you a better chance of getting a good model and of course generalizing appropriately. Then another important aspect is the encoding aspect, then splitting, and lastly feature scaling. Still on data, we have different type of data.
Yes, Said, let me add a bit. Can you scroll up?
Okay.
Okay, so yeah, so this data processing, pre-processing, as I said, he also made mention, for example, that in machine learning, 70% work you do is in preparing data set. What does that mean? But the other 30% is training model. So why do we think that in machine learning, 70% is preparing data and 30% is training model? So what this means is that, for example, you want to, detect hate speech on Twitter. Now, the problem is, how can you even get the data that is hate speech? Because if you want to train a machine learning model, what is hate speech, you must teach it, give it data that is hateful, that is hate speech, example of hate speech, to learn from that. So now you see there are a lot of steps. For example, you need to define what is hate speech, right? And you need to go to Twitter to download the data to get those kind of data that are hateful. You need to give to people to annotate this data, because we told you, like in machine learning, supervised learning, you need to have, train a model data with level. That is, you need to say, okay, this tweet is hate, this is not hate, this tweet is hate, you need to level. So it will take time and effort and money because you need to employ people to annotate this data, right? And it can take some months, 3 months, 4 months, if it is a lot of data, right? And you need to clean, all this stuff takes a lot of time. That is why he said in machine learning, 70% work is in pre-prepared data. But as example here, you can see we are just given an example of data, pumping data. So you don't have any time, like, a lot of stuff for prepare, because the data is already gotten. All you need maybe is to check if there is mid-sum value and other stuff. That is why. But the other 30%, which is training machine learning model, there are existing machine learning model, for example, in Scikit-Lab. All you need is just to plug them and say, okay, run this date on this data. Just in 2 seconds, 2-3 seconds, you just give you the code, your data to machine learning model to run it. And that is it. There is no stuff. So that's why he also said black box. What does that mean is that at this point in time, we are not looking at inside those machine learning algorithms. Black box means we just give them, we don't need to care about mathematical aspect, how this machine learning algorithm works, because there are a lot of mathematics, for example, in regression. There are a lot of mathematics, for example, in SVM, support vector machine. There are a lot of mathematics in support in all these algorithms. But at this point, we are using what we call applied machine learning. Applied machine learning in the sense that we are not looking at the theoretical concept, all those mathematical algorithms. You can look at them, but we can cover later. But now, as a starting, it's just for us to learn how can we just train machine learning model by selecting the algorithm. So that's why you said black box. We don't need to care about them right now. But it is also good if you are good going deeper. Okay, you can continue, say.
Okay, thank you very much, sir. So then we have different type of data. And knowing those type of data will also help you in your various tasks. We have categorical data and we have numerical data. Categorical data in the sense that you can have a data in which you have your option or the data categories, they are what? They are exclusive. Example, like you may have a data that collect the information of people that are either male or female. You can have the information of information that are either old, adults, or teenagers. That information that you have a particular class, bounded class, that say, okay, you have like a pre-selected class that a person must belong to the category, then you can say that's a categorical data set. And it can also be ordinal as well. The other type, the main type, which is numerical, which is qualitative, could be discrete or continuous. Discrete data sets, as the name implies, they are numbers. Like when they say your age, what's your age? You know, your age can be 5, it can be 100. In fact, we have people that, the olden days people that used to be up to like 1,000 years old. However, let's go into the practical aspect to see how this data, or what are these classes, and how can we handle each and every one of them. As earlier said, we need to have all these libraries handy, such as pandas, numpy, etc. So now I'm going to import the data set of this US pumpkin. Yeah, have it imported. I read it with pd.readcsv, and of course, I can see the head of the data set. I can see that I have it starts with 0 as expected. And of course, these are the information it contains. However, from this information, I can notice that like under this type, I can see something like none here. I can see none here under variety. And of course, I can see other with information. I can see all these headings here. And how do I know the size of this data set? Of course, if you like, you can look at the length, or if you like, you can, yeah, if you like, you can say, okay, learn pumpkin.
You are typing in Markdown, not.
Oh, yeah. I can just say, give me the length of pumpkin. Okay, so it gives me the length of my data set, which is 1,757. And of course, you can also check the overview of the rules of the data set. This can be achieved through just pumpkins.columns. This will give you all the headings of the data set. You know, we have 1,757, and we have all these headings. Now, with this data set that we have, and of course, we can view it here, what can we do with this? But we are going to focus on the tags on logistic regression.
Yes, I have questions. So who can tell us, like now we have 1,757. What does that mean? How many in machine learning language? What can we say we have 1,757 what in machine learning?
Records.
Eh?
Instances.
Oh, record, right?
Instances or record, yeah. Number of record.
Yes, good one. Okay, let's move on. Okay, continue.
All right, thank you very much. And then with these records that we have, is one important thing for us to check is, do we have records that are null or that are none that are missing? From the overview here, you can see that we have some places that have missing values here. In fact, this column, like this subvariety, doesn't have anything. This grade doesn't have anything. This type, maybe it doesn't have anything, and maybe some other aspect, other area to have something. So it's important for you to check the head of your data set, the tail, and in fact, the middle. But we have this function, pumpkin.isNull. It will help us to summarize all those missing values under these subheadings. Like under city name, do you have any none? You say no. Under type, that's this type. Do you have any none? You say you have about 1,712. So it means out of this, it only have how many information? It have just like 45 information. But looking at it, you may think it doesn't have any information. But if your prediction is going to be based on this type, then you can be able to extract just the 45 information. Using this formula, at least you know that you have the overview of your data set. You see on name here, then having that information handy, then you want to select some information that have complete data set or that have completeness. That's, we are focusing on those ones that have all the 0 missing value, and of course that they can give us some prediction capabilities. You can see that here: city name, package type, variety, date, low price, high price, origin have 3. Yeah, at least with this origin, you can see you have just 3 data information here, and of course this repack.
Yeah,
Let's say this.
Let me add something. So what we are doing here, you can see we have a lot of columns, right? You may be given a data with a lot of columns, for example, 50. And for example, I said, show us like here, some columns, they are 0. In machine learning, the first thing is to try to do this kind of observation. Number one, for example, all these columns that, they have null, you can drop them, but you cannot proceed to train your machine learning model with, for example, 50 column, 60 column. Some of those columns may not even be related, may not have predictive power. For example, let me give you an example. Assume we want to predict the price of a house, right? And we are given some, properties of houses. For example, the location, maybe it's located at Abuja or Kano. Number 2, the number of rooms. Number 3, the year the house was built. Number 4, the owner of the house. So look at these 4 things, properties: the location, Abuja, the year it was built, right? Number of rooms, the number of rooms, right? Then the owner's name. Owner's name. So you can see here, the owner's name column or name will not affect any predicting the price of the house, right? But the location, the year, the number of rooms can be used to model, to do modeling. When I say to do modeling, to make prediction, but owner's owner's name is not a good property. So you can drop this. So that's what, we are trying to say here, is that not all properties, not all features have predictive capability. Some features, they are there when the data set was created. And now when you want to make prediction, you need to drop them. In fact, when you train your machine learning models with some features that do not have predictive capacity, they will make your prediction to be less accurate, not good. So that means you need to, first of all, try to even look at the data. What are instances, features, they have very predictive power, then you select them. So I think this is what we are trying to do now, to select some columns that they have very predictive power. Yeah, Said, you can continue.
All right, thank you very much, Prof. So having gotten that in our hand, so the next is we want to select those things that have predictive power, and then try to look at which relationship do they have based on the task that we want to predict. So for example here, we want to select package, month, low price, high price, and date from these data sets. We have the heading here. We see that package is here. right? Month. We need the month in which each of these records are recorded. However, we don't have month here. Do we notice that there's no month in our record? But
Yes, sir.
Yes.
yeah, but we can get month from dates. Is that not so?
Yes.
Yeah.
Yes.
Yes.
Having this
Yeah.
information that we can get month from date, that will give us an advantage. Where's the date here? We have date here. This is the month. This is the month, right? This is the day, and this is the year. So we can use some manipulation to extract this month from the dates. And then, of course, the low price, high price are there. Yeah, we have.
Kai ana jin magana ka Abdurrahman. Okay, go on.
Okay, thank you. So we have low price and high price, and of course, we also want to extract date itself. We are extracting this guy so that it will help us, so that we can extract month from the date. So here we created a list, new columns. And from these new columns, we want to extract these guys. We want to remove these guys from the original pumpkins. You know, we already have our pumpkin data here, right? Here we have the pumpkin here, right? So we are now using list expression to extract these headings from the information. If you see that we have 5 headings, right? Package, month, low price, high price, and dates. So now, we now say that for each of this information, I trade through this. If you didn't see any of this, drop it. So let's inspect our new column here and see. So pumpkin.columns, we now have package, date, low price, high price. It returns 4 information instead of 5. Why didn't we have date? Because date is not in the original information. We have not extracted it from the date yet. Hope you are together.
Yes, sir. Yes, sir.
Yes.
sir.
So here now, we now have a new pumpkins. It's very important for us to see what we have now from our original data set. So instead of the head, I now say, let's check the tail here. We can now see that we now have package, date, low price, and high price. We have discarded these other guys here. We have discarded this type, sub-variety, all this grade, mostly low, etc. We just want to focus on what? On the date, package, date, low price, and high price. Can you see how our data set is reducing? However, to extract the month from the date, you can use this particular pandas feature, date time index, to extract information from all the pumpkins dates. You can get for month as well as the price. One important thing you should also notice is that our price, you are trying to predict, like given a particular package or in a particular month, what is going to be the price. But here you have low price and high price. So instead, intuitively, you can say, okay, why not let me take the average of these two prices together? So this is what's happening here. We are taking the average of what? The low price and what? And the high price, so that we can have just one single price. Each package, month, and the price. So with this will give us the information for price, and this will help us extract month from the what? From the date information. Having this, we have price and month ready. So now we need to create a new pumpkin data set that will include the month, the package, low price, and high price. If you like, you can just remove the price from here and just focus on the price, but it can be there just for so that we can see how our data is being extracted from. Having this, we have our new pumpkins here. Then focusing package on the what? Another information, but before I go, I would like to see what my new pumpkins is. New pumpkins dot maybe head, right? Okay, we can see that we have month here now. We have package, we have low price, high price, and of course we have price here. You can drop these two guys if you like, but they have an information that you still want to extract from them. So having this, you are now having an idea that your date has been dropped. You are now using month, right? We have our package, you have low price, high price, and of course, the summation of these two, the average of these two give us the particular price that we have here. So having that, we now want to focus on what? Now the torchlight is now on this guy, package. Let's go and inspect our package in our data sets. So under this package, let's say I try to sort it. We have a package that have 1.1/9, 1.1/2, and you have a package that have 1/1/2. However, we are looking for a package that have this Bushmail. We have Bushmail package, we have cartons, we have inches. Hope you are following. We have LB sacks, etc.
Yes,
However, you want to just focus on Bushmail. So for us to get this Bushmail and make prediction with the Bushmail, we need to what? We need to use regex. We need to use regex, and of course, the help of this string library, which says that if it contains this Bushmail, it should leave it in the pumpkins. But if it is not in the Bushmail, it should leave. So before you extract, you can check the length of these pumpkins first and see. The new pumpkin. You have 1757 right here. Then these pumpkins here, we are on the original pumpkin. We want to remove this guy from the original pumpkin, right? So we are supposed to look for the length of this. Before, well, you have the information of the original pumpkin, which is 1757. Is that not so? But then if you are to remove, after removing those guys, after extracting just the information that have this Bushmail, under package.
Run the last
under
one.
package. Yes, under package, our new pumpkins. This is the information that you are left with.
Yeah, can you show all the new data frame? Just run pumpkins.
Okay.
In a new cell, just pumpkins, not the length.
Okay.
No, not just the, no, okay, it's okay. Yeah, it's okay.
Here. So here, we only have pumpkins that have this Bushmail package. Before, we used to have pumpkins that have all these inches, etc. Yeah, this is the previous pumpkin. Is that not so? It have these LB cartons, 36 inches bins. These are all units, like a particular type of package. But for us to make this prediction or our tags, we just want to focus on pumpkins that have what? Bushmail. So after removing all the other type of pumpkins, we only have how many data now? We have just 415 out of 1,757.
Yeah.
So
Say just 1 minute. So you can see like now here we are still preparing the data to do machine learning, and we are selecting some instances that we want, some examples. You can see it takes a lot of time to prepare. But say this date, is it the date you want to proceed? Like the date, I see you had a month before, maybe, but we have date. So is that correct?
yes, I have the one. This is from the pumpkins. I've not
Okay,
matched.
from the original one.
I have new
Okay.
pumpkins.
Okay, I see.
I have these new pumpkins and I have these pumpkins.
Okay, so go on. We have
Alright.
20 minutes. We can move faster. We have 20 minutes to close.
Okay. All right. Thank you very much. So this is just we are trying to just extract information that we need. Another important information is the normalization. However, well, we see that when we get to question.
Yes.
Okay, go ahead.
Why do you use pumpkin to extract the data? Yeah.
Okay, good. So we use that to extract it so that we will not tamper with this original guy here. Now we have two data set at hand. We have these new pumpkins and we have pumpkins. I hope you are together. Hello?
Yes,
Yes, we are together.
So,
yes.
So
if we like,
mm-hmm.
if we like, we can extract it from here. Here we are just playing with the data set. Here from these new pumpkins here, we can extract it as well. Here we just say new pumpkins. We have new pumpkin here, which is same thing as this.
Yeah, the question is,
give new pumpkin here again.
The question is, why don't you continue with the new pumpkin to select the brochure? You go back to select the with the old data set. Is there anything?
Nothing serious in particular, but this is just, you are just manipulating and extracting stuff.
Yeah.
But here we can still extract it from here.
Yeah, the question
and
is,
extract this guy from here.
Which data set are we going to do modeling now? Is it the new pumpkin or the original pumpkin? Which one?
We are using the new pumpkins.
Okay.
So the original pumpkin is just for us to play around with that particular feature before we merge it with the real new pumpkin.
So we have 20 minutes to.
Okay. So having this, still another important information is normalization. Our data still on this Bushmel guy, we can normalize the price. We see that under the Bushmel, we have information that have 1 + 1/9, and of course, we have another one that have a half. We can normalize this, though we come back to this to see how we can use it deeply in the regression model. But then let's quickly rush to the main regression guy. All the things that we did, we can summarize them here. We have them as import this guy, this guy, up to what? Up to the information here. So this code is going to form the basis of our data pre-processing for our first task of today.
Okay. Let me add something, Saeed.
Okay.
Yes. So Saeed is the last step that he, we have what is called normalization. So normalization is, do you discuss the normalization next step or what? Because like we need to know what does that mean so that people understand why we need it. We are not just using it to, okay.
Yeah, normalization, we go deeper. I don't want to go deep in it now.
Okay,
because
just go on.
normalization will help us to have all our data on a particular range.
Okay, can you scroll up? Can you scroll up? Okay, So if you look at this, guys, you know, the first one here, you can see we have it ranges between minus 100 to 100, right? Minus 100 to 100, which is the data. And you can see that, you know, we have, you know, the range is too large. What I mean by the range is too large is that somebody has minus 100 and another one 100. Now, when you try to train machine learning model with this kind of data, you know, the machine learning model does not learn very well. We try to normalize our data before we train machine learning model. So if you look at this, the second one, you can see the data has been normalized. Look at the distance, 0.0, 0.2, 0.4, 0.6. You can see the distance here, like, you know, 0 to 1. We normalize the data to 0 to 1 in the range of 1. Because if you have, for example, you know, even 1 million, minus 1 million to 1 million, you can see the distance is too far, minus 1 million to 1 million. So one technique in machine learning is to take all the data and normalize it into the threshold of 0 to 1. So all 1 million will be, you know, will be put in this range. No matter what the value is, there is a formula actually that try to, you know, normalize this. So whatsoever the value is will be now be in the range of 0 to 1. I think we will discuss this more, you know, later. But just, yeah, so this is a formula. Yeah, this is a formula. So we have different kind of formulas. We know normalization and standardization. Yeah, but yeah, I will share something. We can check it, but you can continue.
Okay, thank you very much. So this is our data pre-processing stage, and we see how we can how we break down the data set up to the new pumpkin guy. So now let's see what we can do with this information that we have been extracting. This will take us to the next lesson, which is regression model with the help of scikit-learn. In the first class under this topic, Prof. Shamsu told us that regression model is the process of determining a relationship between one or more independent variable and one dependent or output variable. We have various types of regression. We have linear, we have multiple linear regression, we have polynomial regression, and of course we have logistic regression. For the linear regression, which is the most basic type, it's based on this equation that you see. It tried to what? Establish a relationship between y and x. Y is what you are trying to predict given x. You are being given this x and you are asked to predict y. This prediction needs to happen based on the history, that's on the data set you have. Let's say they say you should predict a price of a house. Then you need to look at the information, okay, before in a, to know the price of a house based on the location, the size, the room, you know, is maybe 500,000 naira. Maybe it's located in Abuja. It has 5 rooms. Then the price is 2 million. It's located in Lagos. It has 7 rooms. The price is 7 million. Based on that information, then you are now given a particular city, maybe between Abuja and Lagos. And they now say it has 5 rooms and this. And you are asked to predict what is the room, what is the price of that room. You are going to use the information you have before to estimate that, okay, the price range maybe should be around 1 million. This is what linear regression is trying to do. This y is the price you are trying to predict, given the information. Maybe you are just given, if you are given just one particular information, then it's a linear regression. When the information you are depending on multiple variables, let's say you are not talking of the room type, the location, maybe the materials, the roofing style, all those type, then you are moving into what? Polynomial regression. Of course, provided they are dependent. And of course, this variable, the x that you are working on, is raised to power 1, 2 to n. That's the difference. Here, the dependent variable have powers, whereby in linear regression, the highest power is 0 here. Well, we are going to see how it translates into how this formula translates into real life. So this is an example. You are given months, and then they tell you that a particular bushmeal in January, February, March up to July costs this particular prices. When it's in February, this is the price. When it's March, this is the price. When it's in April, this is the price. This line that you are seeing is the linear regression. Linear regression tries to model what you have for this, what you have for this, so that if there's a new information, for example, this apple that you are seeing here, it just fall here. They now ask when x is equal to $4, you are asked to predict y. And y is what? Y is what information? Can somebody help? What is y?
Me.
Yes, month. So when x is equal to 4, that's $4. Here they are telling you that when the price is $4, can you predict which particular month did they buy it? So what machine learning, especially regression model, is trying to tell you that when this model have been established, you have this your particular line, you have your intercept and your slope. You can easily say the particular price. This is what is inside the black box that you say the machine learning model. The linear regression is one of the simplest machine learning model. So this is trying to tell you that when you are now making prediction, the prediction can fall here. They will tell you that if it is particular, if it is maybe $25, you know, this thing will be around here. Which particular month will it be? Then here you are now going to see how you can generalize your model, and that's when things like normalization comes into play. But for now, let's just say when you have 4, you can see that when you are asked to predict 4, you already established this your formula, y is equal to b plus mx. What is b?
Said, there is a question. Somebody is raising his hand. Lukman.
Okay.
What's your question?
So I wanted to ask, why are we predicting one as a linear regression? I thought it's only for continuous variables.
So linear regression, for what do you mean by continuous value? It can predict real number. What do you mean by, I think month can be like a 2, 3, 4, right? Is that what they are modeling here? I think they are modeling the month by a number. So maybe you are talking about month is January, February, March, April. Is that correct?
Yes.
So I think they are modeling the month here by number, meaning 0 is January, 2 is February, 0 is January, 1 is February. So you can see you are predicting real number. So when you are predicting this kind of real number or continuous, is regression.
Okay. Yeah.
Does that make sense?
Yes, sir. Yes.
Okay. So
Right,
Said, can we continue with the pumpkin? We have less than 10 minutes so that we can.
All right.
Yes.
Okay. Thank you for that question too and the answer. So this pumpkin data set, we'll try to call it again here. This is a fresh notebook. And it's giving us the head of the data set, like we've seen already. So the pre-processing stage that we created in this notebook, we can run it to give us a summary of the data set we need, and it's providing us with what? This information. This is the new head, new pumpkin head. Month, day of year. Here here's an addition, day of year. Day of year is giving us more information more than months. If you see that month 9, that's September, right? So September should have roughly, maybe if you have 30 days per month, then 30 times 9 is going to give us about 270. Is that not so? So this information is trying to give us more information. Then we have variety, city, package, low price, high price, and of course the average price here that has been normalized. So we now want to create a scatter plot between month and price to see the relationship between the data.
So now, before we go on, what are we trying to predict now in this data? What are we trying to model? We are trying to predict the price, right?
Yes, month and price based on this example, yeah.
Okay, go on.
So we are trying to, the month and the price, we are trying to predict the diesel. But before we do the prediction, we need to see the visualization. What are the relationship between the two? So first, we start with the scatter plot. The scatter plot is telling us that between month 8 to 12, these are the information here. You will notice that we don't have January, February, March, up to what? Up to maybe September, right? Or is it October? We only have month 8 up to what? Month 12. And these are the average prices that we have. The highest price is 50 something.
Yeah. So based on our understanding of visualization, is there any relationship between month and price here? We remember what scatter plot used to be. Who can help us what scatter plot used to show us? Who can help us scatter? Because we know each plot convey separate information, right? Given two variables. And now here we use scatter plot. What scatter plot is showing in a plot? Who can help?
It shows outlier.
A part of outlier, not outlier.
Scatter plot helps to show in the relationship. It shows relationship between two variables, especially continuous variables.
Especially what?
Continuous variables.
Yes, continuous. So does these two variables here we have month and period, are they so scatter plot is used to show relationship between two variables to show whether these two variables they are what? Correlated or not. So is there any correlation between these two variables?
Yeah, there could be, but we can't really say. There could be, but we can't really show how they.
Yeah, exactly. Here there is no relationship between. There could be, but here there is no any correlation, because we know if we have correlations, they will be going up. You know, if it's positive, if it's negative, they'll be going. So there is no correlation. Okay, go on, Said. Just I'm trying to interpret so that we understand why we even plot. So the reason why we plot in the first instance is to try to show, to see whether there is a relationship between those two variables. So go on, Said.
All right, thank you very much. So since this scatter plot couldn't give us what you are looking for, whether they are fully correlated, and then we are correlating month and price here, then the other alternative is to check if this day of month is also well correlated with the what? With the price.
Yeah. So you can see here the day of year and price, maybe they are somehow not, not that, positively correlated, but it somehow it shows that it's a bit of correlation between the two.
All right. So here we are not fully convinced. But what is this correlation? When there is a correlation, you are going to have this pattern. A perfect correlation is usually between -1 and 1. When it goes like this, you are heading to +1. And when it's coming like this, you are having -1. When there's a pattern, there's a perfect relationship between all the data points, it's going to move in a straight way pattern or in a curved pattern in such a way that when there's a new data set, you can easily predict it. However, based on our data set here, we are, just like Professor Shamsu said, we are still in the dark. We can't say it's really related. So here, this is the correlation, and here we have the what? The formula for the correlation here for those people that want to follow
You can
it
skip
up.
it. Go on. Yeah.
Yeah.
Please.
So
Yeah.
now we now want what? Calculate the real formula for the correlation. Based on this, here it is negatively correlated. 0.14. How far is minus 0.14 to minus 1? And how far is minus 0.16 to minus 1? You can see that they are not really well correlated. However, between this month and day of year is more correlated than months. Can we see the difference? Here you have 0.1.6, right? At least it's much closer to minus 1 than this 0.14. I hope you are together.
Yes.
Yes.
So based on that, we are going to be focusing more with the day of year. Here we are testing to see, should we use month and price, or should we use day of year and price? So since we have this day of year to be more correlated to what? To the price. So our prediction is going to be based on day of year. So once again, I want to check my new pumpkin. This is 415. These are the extracted pumpkins that we have. And then here we have some data set. We have some data, and we want to plot them to see the various information we have. Here now we are trying to extract, we are now focusing on variety of the data. Still using this scatter plot. Now the telescope is on variety here. We have different varieties, and also, so then we want to see the various variety that we have. So here, the various variety are defined based on this color. And then we want to plot to see each and every type of the variety. So red is for pie type, blue is for miniature, green is for fairy tale, and of course, yellow is for this. So let's say we want to take this variety and then replot it again based on what? The price. Here we are still trying to just see how we can find a correlation between the two to see how if there's a pattern that can give us this thing. You can see based on this variety and the price, this is the bar chart that we have. Still, the bar chart too should also give us a particular hint on whether they are correlated or they are not. We are still in the dark. So based on this, we just pick one particular variety, which is this pie type. We name it pie pumpkins. We are extracting from the what? From the new pumpkins. So having this, then we plot it on the scatter plot again. So here is our new plot. Do you notice any pattern here? So the only way to know whether there's a pattern easily is to use this our correlation formula again, right? So we want to see within these pie pumpkins, we want to check the month and price, whether they are well correlated, and the day of year, whether they are well correlated. We have already extracted these pie pumpkins from the new pumpkins here now. Okay, so now this is what we have now. For the month and price, we have 0.23, and for the day of year, you have 2.6. You see that minus 0.26 is much closer to minus 1. Is that not so? Than this 2.3. So we can see extracting this pie pumpkin and using this day of year with price give us more hope. So after having this, we can see that all these things that we are doing, we are still working on our data set, trying to look for insight, trying to look for correlation to see which one should we use for training our model. So now, we not say we have exhausted all our options, but now we want to start training the regression model. So this is from sklearn. We are importing linear regression. We are also importing mean square error. This is for evaluating the model. And of course, the train test splits. We've already seen this one a couple of days ago. So I've imported them. Our X have our pi pumpkins based on day of year. We are changing it to NumPy so that we can easily train with it. Is that also? Let's quickly see the information here. So for this X, these are the features here we have. The day of year. Is that also? This is the day of year. And this is the what? This is the price. This is the normalized price. You can see this is X and Y features. So now we are trying to split it into train set and text set. Is that also? And we are using test size to be 0.5. This 0.5 means we are using 20% for what? For testing, and 80% for what? For training. So we've splitted it, and then here it fit our model. We are fitting the model with the train set and what? And Y train. That's the input data and the label. So after running this, we now want to see our what? Our coefficient, linear regression coefficient. And of course, our intercept. You know our coefficient, when we see Y is equal to A plus
MX.
BX, MX, yes. So that M is the coefficient. And the B is the what? Is the intercept. Thank you, sir.
So can you go up a bit? So yeah, no. It's go down. Yeah, go down. Yes. So we can see here, just, Sahid, we start training machine learning. So you can see this is just the part we start training machine learning. Everything at the top is trying to understand your data, to prepare your data. So you can see here, you just import some stuff to do everything. And now he started working on the machine learning. Continue, Sahid.
Okay, thank you very much. So here now, we have our guys here. We have the intercept and of course the coefficient. However, a quick one, we say a correlation will have a perfect line. However, what is the error that is in this guy? You know how good this machine learning or this regression model have worked? We can use what is called mean square error. Mean square error is a process whereby you use this Y that you train and the predicted, you take the difference, you now square it. You now sum all the squares of all the data points or all the records. The answer that you have is called mean square error. So in time, okay, just a minute, sir.
No, go on.
So if you look at this dot, these cycles here, they are just imaginary. Let's say this is how your data point is. You have a point here, 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 a point here. And your model has been trained. When you have different points here and you couldn't have a straight line that can pass through all these points, then you are going to be having more errors. Had it been your points fall here, these shaded points, observed value are here, this one is here, this one is here, then your mean square error will be around 0.0.
To add quick one. So here, after you train your machine learning model, your machine learning model may not be perfect. It should be like a kind of good, but it's not perfect. So what Said is trying to tell us here, a perfect machine learning model, when you train, it should fit into this dot, you can see straight line. But when you train your machine learning model, it may not fit perfectly. You can see the first one is something, a little bit top, you can see. Yeah, that one. And the next one is top there. Yes. So we need to find what is called MSE, mean square error, which find what is the error you did in your prediction. So this is a formula that does that, but don't care about this formula. Scikit-learn comes with the formula automatically. You can see here, oh, here Sahid is using the mathematical formula, but scikit-learn also, oh, we have it MSE here. We have the, okay, you calculate the MSE using the mean square code, okay, mean square and, you know, y-test and predict. So you can see here, we have the y-test and the prediction, and you are taking the square root. Yeah, so this doesn't show the square root here, say the complete formula. Oh yeah, we have the square.
Yes, this is the mean square error.
Yeah, this is the mean square error, right?
Yes. So this is now taking the square root.
Mm-hmm. Yeah. So yeah, continue.
Okay.
I think we need to average.
Sorry?
Yeah, I think we need to take the average from the formula. We have 1 over n followed by
Mean is average now. Mean is another name for average. So it's already part of the formula. The 1 over n there covers the average. That's the mean.
exactly.
Yeah. Okay. I hope you are all following.
Yeah, continue.
All right. Thank you, Dr. Falalu, for
you
chipping in as well.
Yeah, you should go faster, or we can stop here because it's already, we have 10 minutes on top of it. So yeah.
Okay. Okay. Let me quickly rush it then. All right. So we have mean square error based on this prediction that we did here between the day of the year and of course the price. And then now here, okay, here we have alternative way of checking how good our prediction here is using this guy, coefficient of determination. I know you can just read on that. So now you want to plot the the regression line. This is how the regression line is. An error. Okay. Having okay. Okay. So here, based on the data that we have, we can see that this is now our linear regression. You see how the data are scattered all around. It's not well fitted on it. These data are supposed to be very close to this line. That's when you see that you have a very good model, but here we are just doing this for a regression purpose. So that's just linear regression. Now we are now moving into polynomial regression, whereby we can use different variables.
Said, I think we can stop here at linear regression, and in the next session we can cover the polynomial because we are already 43 minutes and we're supposed to finish stop at 9:30. So yeah, so let's use this opportunity now to ask for questions before we move go. I think because it's already time, we can continue with the session on Sunday or Saturday, I think. Yes, on our office, one of our office hour. Yeah, so let's ask for a question. A question, please. Any question? So I will encourage us all, this session is just trying to, is for us to go through the, existing material. But if you see that in the material, they also have a video, right? They also have the code. So try as much as possible to watch the videos, the walkthrough in the video they have, and run the code. Now, when you come here, you will come with predefined questions, set of questions, because you already go through and you have some questions that you want to ask us. So when we come to this kind of, session, it will not be like we are going into the nitty gritty of everything, but we're going in the lighter space, at the, not that kind deep. We would be attempting to ask questions you have. So what I would advise is that, try as much as possible to watch the recordings and walk through the code and come along with your questions, and so that we can have more kind of, interactive session where you are asking questions and we are going through the stuff.